Hi there, this is Penelope. What we're looking at in this video is how to find the root mean square of a function. Now, if you're doing electrical engineering, you'll know what it is. For most of you, if you just ask to find it, it's just something you've got to find. It's another one of those things where we're using integration in a formula, and you're in a formula that you are given. Okay, so for this one, the question is this. It says find the r.m.s of the function t squared across the interval 0 to 1. So you're given the formula there, so the r.m.s, the root mean square, is going to be equal to the square root of, just filling it in, 1 over 1 minus 0 times the integral from 0 to 1 of t squared 1 over 1 minus 0 is just 1. Now, t squared is t to the 4th, so that's t to the 5. The integral of that is t to the 5 over 5 between 1 and 0. So, ignoring the 1, that would be 1 over 5 minus 0 over 5. So that's the square root of 1 over 5. You could leave it as 1 over root 5. Or you could say that that's approximately equal to 0.447, just 3 significant figures. So all you have to do is just use the formula that you're given. For another example, let's find the r.m.s of the function where you've got a sine in it, and across the interval from 0 to pi. Now don't forget, your calculator must be in radians, because you're doing calculus. So set your calculator now. Okay, so this is going to be equal to, I should line up my equal signs, but I may run out of space. I can't change that. Okay, so it's going to be 1 over pi minus 0, which is just 1 over pi, times the integral from 0 to pi. Now, we know that ultimately we're going to have to do a little bit of trig substitution in here. There's a video on that, how to integrate sine squared. So if you don't know, go back and check. What you have to do is you have to make a substitution like that. Before you've done the integration, before you've done the square root sign, I'm going to take out the 2. And so that leaves me just having to integrate 1 minus cos 2t with respect to t. Alright, the integral of 1 is t, the integral of cos 2t is sine 2t over 2. Now I've got to do that between pi and 0, and if you're careful with the calculator, it's going to be 1 over 2 pi times pi, which leaves you with the square root of, because we can cancel, 1 over 2, or 1 over root 2. You could leave it like that, or you could approximate that to 3 significant figures. As the last example, let's find the r.m.s of a cos function, and it's across the interval 0 to pi. So using the formula, it's going to be the square root of, and again 1 over pi minus 0 is just 1 over pi times the integral from 0 to pi of cos squared dt. Now again, go back to the earlier video on integrating using trig substitutions to do that, and you find that that's t over 2 plus sine 2t over 4. And now plugging those values in, 1 over pi stays out the front, And I'm going to bracket my two terms separately. So sine 2 pi over 4 minus 0 over 2 plus 0 over 4. Tidying that up, I am going to, from the first term, multiplying these two together, I'm going to have 1 over 2 plus I'm going to have sine 2 pi over 4 pi and sine 2 pi is 0, so that's gone. So again, I've got the square root of 1 over 2, which is approximately equal to 0.707. So this is yet another application of integration. The integration itself is not hard. We've done integrals of cos squared, we've done integrals of sine squared, and you just are given the formula, just do the integration as required.